Welcome to physics class. My name is Mr. Babalola. So today we want to look at waves. At the end of this lesson, all the students will be able to define the term waves, list the two types of waves, and some of the students will be able to explain the generation of mechanical waves. What is a wave? Before I tell you the meaning of wave, let's look at this. So this is a pool of water. If a stone is dropped into a pool of water, the following things will be observed. You will see that the water is disturbed when the stone hits the water surface, and you begin to see ripple traveling out from the point where the water is disturbed. So this movement or the traveling of the ripple is a form of energy, and we know that energy due to motion, that is kinetic energy, meaning that in waves, 1, there is disturbance, 2, energy is transferred, and this energy does not cause permanent displacement on the medium. So a ripple is a traveling disturbance called a pulse, and the motion of the ripple always from the point of disturbance is called wave motion. So you see the wave moving. So the motion of the ripple away from the source or from the point of disturbance is the wave motion. Then what is a wave? A wave is a disturbance which travels through a medium. And when we talk about medium, it can be water, can be a syringe, can be to one particular object or the other. And there is transfer of energy from one point to another without any permanent displacement of the medium. Again, a wave is a disturbance which travels through a medium and transfer energy from one point to another without any permanent displacement of the medium. Now we have two major classification of waves, or the two types of waves. One is mechanical waves, and the second one is electromagnetic waves. Those are the two types of waves: mechanical waves and electromagnetic waves. So what is a mechanical waves? Mechanical waves are waves that requires a material medium for their propagation, meaning that for those waves to occur, there must be a material medium. No material medium, no mechanical waves. So for mechanical waves to occur, there must be a medium. And we have examples of mechanical waves: sound waves, water waves, wave in swing, wave in rope, and so on. So for mechanical waves to exist, there must be a medium for their propagation. So a mechanical wave needs a medium to transfer energy. Like when we look at that water waves, for that pool of water, when you drop the stone, you can see ripple moving. So you can see ripple moving. So for that mechanical wave to occur, for that water wave to occur, there must be a medium. So water is the medium for that water waves. And what is electromagnetic waves? Electromagnetic waves are waves that do not require a medium for propagation, or that do not require medium for their propagations, meaning that they can travel in vacuum. They do not need any medium. And we have examples: radio waves, microwaves, infrared waves, visible waves, ultraviolet waves, X-rays, gamma rays, and light waves. Those are examples of electromagnetic waves. Don't forget, we said we have two types of waves: mechanical waves and electromagnetic waves. And we said mechanical wave needs a medium for its propagations, while electromagnetic waves, they do not require material medium. And electromagnetic waves, as we said, can pass through a vacuum, and they pass through a vacuum at a constant speed. So all electromagnetic waves, radio wave, microwaves, infrared waves, visible waves, ultraviolet waves, X-rays, gamma rays, light waves, they travel through a vacuum at a constant speed. And this constant speed, we call it the speed of light, c. And this speed of light, c, is equal to 3.0 times 10 to the power 8 meter per second. Meter per second. Please take note. 3 times 10 to the power 8 meter per second. And these electromagnetic waves, they consist of electric field and magnetic field that are perpendicular to each other. And we know when we talk about perpendicular, that is at angle 90. So electromagnetic waves consist of electric field and magnetic field that are perpendicular to each other. As we said they do not require any material medium, and they travel with constant speed. So all electromagnetic waves travel with the same speed, which is the speed of light, which is 3 times 10 to the power 8 meter per second square. Now let's look at production of mechanical waves. If you remember, we said mechanical waves, there are types of waves, and those are waves that do not require a material medium for their propagations. And now, for we to study water waves in the laboratory, in physics lab, we need an instrument known as ripple tanks. And a ripple tank is a shallow tank with a glass base. So you have a rectangular shallow tank, and at the bottom is made up of glass. So you can put your water here, and you look for a dipper. So the dipper acts as your vibrator, disturbing the water, touching the water surface. As it's touching the water surface, there is production of ripple. And you see this ripple traveling, performing wave motion, moving. And we can now study these waves, or we can study these water waves in the laboratory with the use of ripple tank. And don't forget, water wave is a mechanical wave. So there must be a medium. There must be a medium for its propagation. And the type of dipper you use to perform the disturbance will determine the nature of the wave front. So if you use a straight dipper or a plain dipper, you will have a plain wave front. And if you use a spherical or a circular dipper, you will have a circular wave front. We are going to talk about that next class. But now to summarize this, for the production of mechanical waves in the laboratory, we use a ripple tank, and it consists of a shallow tank with a glass base. Now, apart from water waves being a mechanical wave, you also have wave in string. You also have wave in ropes. So we can demonstrate this. So as you can see, this is a string or a spring. So if you push the spring from the free end back and forth, if you push it this way, as you can see, this end is fixed. If you push it this way, it will move back and forth, back and forth, back and forth, producing compression and rarefaction, producing compression and rarefaction. And this compression and rarefaction are characteristics of longitudinal waves. We are going to talk about that later in this video. And what is compression? Compression is the region of high particle density. As you can see the spring here. They are close together. And rarefaction is region of low particles density. As you can see the spring here far apart. So we have compression, rarefaction, compression, rarefaction, compression, rarefaction. So this is also an example of a mechanical wave, that is wave in spring. Also, we can have it in ropes, where one end is fixed, then the one end of the rope is fixed, and the free end is moved up and down. So move it up and down, see it moving, and you see the pulse. See the pulse moving up, down, in that manner, and you see the wave traveling. See the wave traveling to and fro. So, in the generation of mechanical waves, or in the production of mechanical waves, for water waves, we use, in the laboratory, we use a ripple tank. And this is production of wave or mechanical wave in a spring, where you fix one end and you move the spring at the other end back and forth, and you see two regions forming, region of compression and region of rarefaction. And if you move the spring or the rope, if you move it up and down, then you have another region, which is pulse, or region of crest and region of trough. We'll talk about that in our next video. Now, let's look at the classification of waves. Don't forget, I said we have two types of waves: mechanical waves and electromagnetic waves. Now, we can also classify waves. When I was explaining this, I was talking about compression and rarefaction, and I was talking about crest and trough, which we are going to discuss next class. So there is a way of classifying them under transverse wave and longitudinal waves. But for today, we have two major ways of classifying waves. One, by material medium. So you can classify waves by material medium, and you can also classify waves by modes of vibration. So classification of waves by material medium, we have mechanical waves and electromagnetic waves. So classification of waves by material medium, we have mechanical waves and electromagnetic waves. And classification of waves based on modes of vibration, we have transverse waves and longitudinal waves. In summary, we say wave is a disturbance traveling through a medium, transferring energy from one form to another without any permanent displacement of the medium. And we said we have two types of waves, mechanical waves and electromagnetic waves. And mechanical waves, they are waves that requires a medium for their propagations, and we have seen the examples. And we said electromagnetic waves, those are waves that do not require a material medium for their propagation. And we can study mechanical waves, example, water wave, with the use of a ripple tank, in the laboratory. And wave in spring can be demonstrated by looking for a spring and fix it at one end, and you move it back and forth. So, and you will see region of compression and region of rarefaction. Then if you move it up and down, you have crest and trough. And we have two major ways of classifying waves. One, by material medium, which is mechanical waves and electromagnetic waves. Two, by mode of vibration, which is transverse wave and longitudinal waves. Okay, this is your assignment. Examples, give examples for mechanical waves and electromagnetic waves, and define the following: transverse wave and longitudinal waves. Thank you.